we got one question sent in, and we'll go over it, but I don't have any other questions, so that means y'all must be understanding everything.
No.
Okay, well, you need to start sending questions. You sent me some?
I thought I did.
Well, send me some right now and see if it works. All right. This kind of plays into what we were doing the other day. What is the vertical shift? Vertical shift is 10. So, go here. What kind of family of graphs? What is it? X squared. What is it? Here's the family of graphs.
Parabola.
Which one is it? It's the parabola. Okay, how do you know that? Look at your family graphs, your parent graphs. X squared is a parabola. So, how do you know, and this is where we're going to get into this a little bit. You actually, it's 10. 10 is going to be your vertex, I think. But how do you do the other? Well, then you'll have to let me just go ahead and do this problem. And I'll show you, and I'm going to tie a little bit of chapter 3 in here, okay? But don't have a conniption because we haven't went over it yet. But I'm going to use a little bit of completing the square, and we'll go from there, okay? Let me get my whiteboard up. It's the only thing I didn't pull up. I have everything else pulled up. There we go. So everybody can see my whiteboard, right? Hopefully y'all can see it, Pendleton and Oconee. We know that the y-intercept is what? Or the vertical shift is 0, 10. We know that from that right there. Or you can plug in 0 for x. If you plug in 0 for y, you're going to get the x-intercept. So let's do that. X squared plus 10 is equal to 0. And now we're going to bring the 10 over, and that's going to give you x squared is equal to negative 10. Now, if I take the square root of both sides, I get x is equal to 10i, square root of 10 times I. And this tells us, that right there tells us no x-intercepts. Because you can't take the square root of what? A negative. So we don't have any x-intercepts. But we can use complete the square, but it's not going to help us any because it looks like to me that it's going to cross. Let's use our x and y, and of course you could use your graphic calculator. -2, -1, 0, 1, and 2.
Question.
Yes, what?
Where did you get the I from?
Okay, we'll get into that later, probably in chapter 3 or the latter part of chapter 2. When you take the square root of a -10, you change that into the square root of 10 times the square root of -1. And the square root of -1 is I. But we'll get into that later. All right, what's -2 quantity squared? 4 plus 10 is? So a 14 there and a 14 there. What's -1 squared? 1 plus 10 is 11. And I'll do this one for you. 0 plus 10 is 10. There we go. All right, so basically 0, 10 is going to be your vertex. So we take our handy-dandy graph maker, or whatever you call it up here, and we click on this, and we say, okay, it's going to be a parabola because it's a x squared function. And I'm going to put the vertex at 10. So there's 8, 9, 10. And then I'm going to pick a point from my graph right here. So what, -1 and 11?
Yeah.
-1 and 11. And look up in the top right-hand corner, you see -1 and 11. And maybe one more point. How about 2 and 14? 2 and 14. So I'm going to move it till I get 2 and 14. Oop, there we go. And click it. And you feel good about yourself. Check. And it's probably not going to like that other one, so we're going to have to go back and take that one out. Can you clear it? Delete it? There we go. Now let's check it. We feel good about ourselves. That is a test question, but it is 1.2, so we'll get to that today. But again, there's some things there that you should know. You should know that the square root of -1 is I. Okay, if not, then we'll go over that. But that's the only question I got. Did you send me some? Did somebody?
I did. It said it.
It did? Okay, let's look. There it is. Evidently, you didn't send me any because I just got it. You lying to me, Miss Porter. I'm very disappointed. All right, 2.5. You on 2.5 homework?
Because I thought you said go all the way to 2.6.
Good gracious, girl.
So that's why I stopped.
Okay, that's piecewise function, but we'll go ahead and look at it since you sent it. We'll go ahead and look at it. I'm not saying that you need to be there, but I do know that this first unit we have a lot of people that are kind of moving along, and some people are kind of moving slow. So eventually, everybody's going to level out. Eventually, y'all will get to a point, especially complete the square. Most of you are going to suck at it or be slow with it, and eventually it's going to level out. So just believe me, I've been teaching for a couple of years. All right. So draw a graph. So take your handy dandy straight edge maker. Ooh, no, let's don't do that. Let's kind of make it thinner. There we go. All right, so make a graph. And we know that both of these are straight what? Lines. How do you know they're straight lines? Because it's x to the first power, and this one is y is equal to -2. That's y is equal to -2. That's a horizontal line. So let's go ahead and draw that one. Let's do this one. I'm going to highlight this one. I'm trying to draw with my mouse. I'm always trying to do better things. If I can draw with my mouse, it's pretty good. It's kind of hard to do. Okay, then we're going to make that one green, verde. So I take my handy dandy straight edge maker, and we're going to color it at -2, and I'm just going to draw it, and then I'm going to go and erase it. So -2, x is equal to y is equal to -2 is right here. So that means we got a line going like that. Everybody with me? Okay, so that's the green line. So let's go and make because I want y'all to complain about it. Let's make it yellow so you will complain. I can't see, I can't see. Yeah, that's what y'all will say. I can't see, I can't see. All right, so x -4 means we've got a straight line going on 1 to 1 at a 45-degree angle because the slope is 1/1. Okay, so that's a 45-degree angle. What is the vertical shift? -4. So I go down here, and then I do a 1 to 1. Okay, and it looks. You ready? I can't see. I can't see. Okay, so there is your two lines. Oh, I forgot to highlight. Sorry. I don't want to lead y'all astray. There we go. There's your two lines. Now that you got your two lines drawn, you need to look at the domain. So take your handy dandy eraser. And what is the domain for the yellow? All numbers less than what? Less than x is equal to 2. So that, let's say x is equal to 2. Let's say it's right here and right there. Okay? So I'm going to erase everything above 2. Everything above 2 is right here. So I'm going to, it's probably going to erase the whole thing. Yep. So I'm going to redraw my yellow line at just 2, right about here. Okay? There's my yellow line. It's not straight because I don't know why it didn't make a straight line. Probably because I didn't hit it. Let's try it again. There we go. There's my yellow line. Now, why didn't I draw it up here? Because the domain says that all your x values for the yellow line has to be below what? -2, so this way. Okay? What does the green line say? So I have to use this line, and I'm going to make it a little bit thicker. So I'm going to make this line green. I'm going to make it a little bit thicker. And I'm going to go from here that way and erase my other one. Everybody with me? And that should be it. So all you have to do now is find the graph that looks like that right there. I say bravo. What do y'all say? You say alpha. Well, let's see. You're wrong. I'm right. What does Squidward say? I'm a winner. See my prize. You're a loser who sits in prize. You don't remember when Squidward wanted to win the video game, the claw?
Oh, yeah.
You know, and the little kid come up there and lost. And, yeah, that was a funny episode. Gave his house up. Mr. Krabs took the house. You know. Okay, so that's how you do a piecewise function. We'll get into those. Okay, so let's go to our handy dandy. Now that we've done that, let's go to what I skipped over with y'all yesterday or the day before, whatever. And that is the symmetry around the x-axis or the y-axis or the origin. Now, if you want to see if a function is symmetric around the y-axis, f of negative x must equal f of x. And we're going to do that in just a second. But write that rule down. F of x is equal to f of negative x. So that means you're going to plug in negative x into the function, and if it comes out to be the same as the original function, then you know it's symmetric around the y-axis. Go ahead. What'd you say? Y'all gonna whisper and grumble because I can't understand those two. You need to speak up.
Not with the talk.
So, let's look at the next example. It's a family of graphs. But there it is, x to the third power. Wait a minute. That's around the origin. Okay, write that one down, and then we'll do an example. This is around the origin. F of negative x is equal to negative f of x. And then we'll do an example.
Excuse me?
Yes.
So when I did this, I got when it's even, it's y symmetry. When it's odd, it's symmetry around the origin.
Yes, that's right. And it should say that. It might say it here in a minute. Yeah, even is around the y-axis and odd is around the origin.
And x symmetry is not a function.
Yes. If it's symmetrical around the x-axis, it's not a function. Because then you have a circle or a hyperbola. Whisper. F of negative x is equal to negative f of x. So when you plug and chug, you're going to see, hopefully they'll give us, there we go. Show that each of the following is true. So f of x is equal to x to the fourth minus 3x squared minus 8. So plug that in, plug negative x into wherever there's an x. Plug that in and see what you come up with. I'm going to take my hand. Where's my whiteboard? My whiteboard disappeared. Hold on a second. whiteboard is gone. Damn Russians. You know, them Russians are into everything. There we go. Now hit from, there we go. Come on, you can do it. There we go. So, if I take my function, my gosh. If I take my function, I like black, I don't like red. All right. Parentheses to the fourth power minus 3 times parentheses squared minus 8. And I plug in a negative x. What do we get? Well, what is negative x to the fourth? What do you get? You get a positive, right? X to the fourth, right?
Right.
And what do you get when you have negative x raised to the second power? You get x, right?
Right.
So that's going to come out to be negative x squared. So, what do we get when we plug in negative x? You get the same thing. So that means that it is, what'd you say, even? That means it is symmetric around what axis?
The Y.
Symmetric around the y-axis. Because I got the same thing I started with. But here, plug in parentheses minus 4 times parentheses, plug in a negative x. What do we get? Well, what happens to this guy? X, negative x to the third. What is this? Positive what?
4.
Now let's take a negative and put it in front of this guy and distribute that negative. What do you get? Negative x cubed plus what? This is negative f of x. This is f of negative x. What can you say about f of negative x and negative f of x? They're what? They're equal. So that means that you have odd function, which is symmetric around what? The origin. I don't usually ask that question on many tests, but you need to know how to do it. I mean, you plug in, you got to know those first two rules though. You got to know, hold on, you got to know that rule, and you got to know that rule. So make sure you write that one down, and make sure you write that one down. Yes, sir.
So if the exponents of x are all even, it has to be y symmetry.
Pretty much, yes. You'll start to see that after you do it. And you won't need to do this. Okay? Most of the time when you have a square or a fourth, you know it's going to be a what? It's going to be a parabola. So, and then the odd functions, what do they come out to be? They look like this. Logarithm different. Okay? Because you can't take the log of a negative number. So you really don't have symmetry with a log because you can't take the log of a negative number. So anyway, so make sure you can do that. You might see it on a standardized test, but I'm not going to test you on that. I'll test you on it graphically. You know, draw a graph and tell me if it's symmetric or not. I'll do it that way. But anyway, next question. Our next slide. Okay, again, we just did that one, I think, and there it is. And you get f of x. Did we just do these? Okay, they did them on a separate slide. I did them on one slide. Sorry. And if you look, you see that this side looks like this side. And this is a saddle. Make sure you make a note of that. That type of, and remember, did I talk about hidden behavior?
Yes.
Make sure you always blow up if it's a large make sure you blow up the bottom, because sometimes you could have a fourth or a sixth or an eighth power. You can have hidden behavior. So be sure. And instead of having a vertex, you have you have two local mins, and you have a local max right there, which we'll get into that later. And there's that function. And you see it's the normal cubic function, so it looks like that. Again, you have a local max and you have a local min instead of just a turning point. Also, what's 3? This is the third degree. What's 3 minus 1? 2, so you have 2 turns. Okay? Next. And there's square root function. We talked about all this yesterday, so I'm not going through this. Cube root function, I told you to add to your parent graphs. There's absolute function. We said it looks like a V. And there's inspection of the, there's what you were saying a while ago, the even function and the odd function. And if it's symmetric around the x-axis, it's not a function. And those are 3 examples right there. So write those 3 down, and we'll go through and plug and chug and see what we get. In fact, go ahead and plug in negative x, and go ahead and see what you get, and then put a negative in front of the function and distribute it, and see which one is equal to. No humming in class. Yeah, don't do that. Can't call, yawn, sneeze, sniff, or you got, or can't do that. Just breathe. So Georgia plays Dorman this weekend, and South Carolina, I don't know who they play. Anybody ever look it up? Okay, I'll look it up, don't worry. Y'all are so busy and concentrate.
They play UNC.
Oh yeah, that ought to be a battle. Don't be surprised if South Carolina gets beat.
They play Charleston Southern after that.
God.
Then they play Alabama.
Oh, that's even better, you know. Let's play 2 cupcakes and then play a good team, you know. And then they play what? Oh, yeah. So, the first one, I'm going to plug in negative x. So, 8 parentheses to the 4th. I don't know how this thing does this. Every time I write on the left side of this board, it goes bonkers. Minus 3 parentheses squared, plug a negative x in there. And basically you're going to get 8x to the what? 4th minus 3 what? X to the 2nd. So this looks like this. So you can say this one is what? Even? 6 parentheses cubed minus 9 parentheses. Plug in a negative x. And we get 6 negative, what is negative x to the 3rd? That's going to be what? Negative x to the 3rd. And then plus what?
9x.
Well, that's not equal to this. But if I was to take a negative and throw out in the middle of this, in front of it, 6x to the 3rd minus 9x, what would I get?
Same thing.
I'd get negative 6x cubed plus what? 9x. This is f of negative x, and this is negative f of x. So these two match, therefore, these two are, this one is odd. And then the last one, 3 parentheses squared plus 5 parentheses negative x, you're going to get 3x squared minus 5x. This one is neither, because that does not equal that, and if you did a negative in front of this, you would get negative and negative, so this one is neither. Is it NI? Is it NE or NI?
NE.
I got it right. And you feel good about yourself. So you don't have to put smokestacks on your pickup truck. So the first one is even. The second one is odd. And neither. And that's 5.1, or what chapter are we on? 2.1. So let's go to 2.2. Oh yeah, we got to discourage you. Try to discourage you. No, I can't do that. Somebody will complain. Somebody will call my boss and said he only went over one section a day, and I really wanted him to go over two. Bet me. I'll bet you a daggum $100 bill somebody would call my boss and say he only went over one section a day.
I'm going to not complain to you.
I know, well. Vertical and horizontal shifts. Now, we've already discussed this, so this shouldn't be hard at all. Okay, I'm not going to talk about that because, here we go. Let's see. Okay, there's a prime example. Now, when do you know if the horizontal shift or is it a vertical shift? Always remember, the horizontal shift is connected to the x within the function. Okay? When you have something squared, something to the third, something absolute value, you're going to have parentheses, right? Or you're going to have those marks. If that number is within those marks or those parentheses, that's the horizontal shift. Outside of the function, which would be in this case the absolute function, if I had a +1 outside of the marks or a -2 outside of the marks, that's your vertical shift. Your vertical shift is always going to be outside the function. What do I mean by the function? Well, if I take my handy dandy highlighter and I highlight those two marks right here, the function is those two marks. What is those two marks? What do they represent? Absolute value. If it was parentheses and square, then that would be the squared function. If it was parentheses to the third, that would be cubic function. Anything outside of those marks or outside of those parentheses or outside of whatever, the square root symbol, that is a vertical shift. If it's within the marks, that is the horizontal shift. That's why I showed you those three different examples, and the H was always inside the parentheses. Okay? And that's what they're telling you here. So we've got a horizontal shift of 4 to the right and 2 to the what? Left. Remember, the horizontal shift is always the opposite. Supposed to be presenting this. Oh, me. Can y'all tell today's Friday? Can't? I can. So, look at these two. We're not going to draw them yet because what is the horizontal shift on the first one? To the what? To the left, and how many down? 6 down. It looks like a V. What's in front of the absolute value mark? A 1. So that means this is the basic model, which means the one that's on your parent graphs is going to be, that 45-degree angle. All right? Same thing here. The 1 is in the front, so that means it's your basic model, which is that 45-degree angle. Anything, if it was a 1, if it was a 2 or a 3, it would be narrower. If it was 1/4 or 1/5, it would be what? Wider. So a horizontal shift of 2 and a positive shift, vertical shift of 8. So this one is going to be left 2, down. So it's going to be in the what quadrant? Third quadrant. This one is going to be in the what? First quadrant. So third quadrant, first quadrant. Third quadrant. The other one's going to be up in here in the first quadrant. Now that's a good example right there. So you see how it goes over to the left? And of course, when y'all start sending these questions, we'll be going over them. And there's the first quadrant. 2 to the right and up 8. Now what if I had a 1/2 in front of this? Then that would be a wider, so you draw it like this. It's 1/2. Now, is there going to be somebody sitting here with a bat and hit you upside the head if you don't draw it exactly right? No. Remember, these are sketching. You're sketching the graph. You're not plotting points. You're sketching. So the thing you would do, you would take your handy dandy, let's see, I like black. Okay. We'll use blue. Okay? I would draw it like that if it was a 1/2 out front. Like that. If it was 1/4, I'd draw it a little bit what? A little bit wider. If it was 3, I'd draw it what? In the middle. Because your black, the black one right here, is pretty much your basic model, your parent graph. Because the parent graph is when there's a 1 here. Okay? And if there's nothing there, it's assumed to be 1. Because it can't be 0, because what would 0 do to the whole function? 0 it out, Hubert. That's right. So it can't be 0, so it has to be a number. Next. Okay? All right. These are your test questions right here. Okay? This section right here is where you're going to start seeing a lot of test questions. 2.2. All right? So what's the domain? And I'm going to take my handy dandy highlighter and we're going to highlight it in green, verde, orange, red. So the domain of this function is negative infinity to what? Positive infinity, because it has what? Has arrows. What else? Well, it's not a rational function. Why? Because a rational function looks like a what? A volcano or a half of a volcano, right? And it's not a radical function, because a radical function would be like a what? A swoosh. How do you know that? You know your parent graphs. That's why I told you to write those down. You don't just write them down, you need to learn them. Okay? This is a cubic function. All right? What's the domain of anything to the first, second, third, fourth, fifth, sixth? What's the domain? All real numbers. Has that arrows, so that means these arrows. Negative infinity to what? Positive infinity. This arrowhead is negative infinity. There's something wrong with the left side of this board. And this one is positive infinity. What is this is a radical. A radical, the domain is affected. The domain is only from 2 to what? Okay, now let's talk about the range. Dang old yellow. Dang old Amarillo? Amarillo?
That sounds right.
Yep. Dang old C. All right. So let's usually look from down to up, although some people keep their nose up in the air. Normal people usually, look up. When you're walking down the sidewalk, you usually look down, and then when something comes up, do like that. So where do you hit the function? At 2, and it goes where? Goes to infinity. So that is your range. What's the range here? Well, on all cubic functions, fifth functions, seventh functions, it's going to be negative infinity to what? Positive infinity. What about this one? From negative 3 to what? To positive infinity. Now, I like to ask graphical domain and ranges because it's very important that you be able to do that. Capiche? Now, do you have to write negative infinity to positive infinity? No, you can say all real numbers. You can say all real numbers in the range if you put a little subscript y. You can do that. So double R and then little y. Okay, so on the second one, I would do all reals, little x, all reals, little y. That tells me that all real numbers on the y-axis, all real numbers on the x-axis. Or you can do the humdrum parentheses, negative infinity, comma, positive infinity, close parentheses. And then the range on the first one would be 2 to infinity, 2 comma infinity. And of course, this is not increasing and decreasing, so you can put a bracket on 2, you can put a bracket on negative 3, and you can put a bracket on 2. Now, if I ask increasing and decreasing, you can't put a bracket on the vertex because you're neither going up or down. So if I ask for decreasing and increasing values on A, it would be negative infinity to 1, and then 1 increasing from 1 to what? Infinity. The good thing about a cubic or a fifth or a seventh function, what's the whole function doing? From left to right, what is the function doing? It's increasing. It's increasing from left to right. If you don't know, put a little car on the left-hand side of the graph and tell me what that car is going to be doing. It's going to be going uphill. Why on the left? Which way do we read? Unless you're from Middle East, Masalama, then it's left to right. So what's the car going to do on A, left to right? It's going to go downhill until you get to the bottom, which is at 1, and then you're going to what? Go uphill. Remember, the only one that is in terms of y is what? The range. It's the only one. Everything else is in terms of x. Okay, what is the domain from 2, bracket 2 to infinity? And then what is your range? Bracket negative 3 to infinity. Capiche? Y'all feel good about yourself? Pendleton and Easley don't say anything, so we'll just take them at their word. Positive 1, you got a 1 to the right and 2 up. 1 to the right and 2 up. This is 1, so that means it's a parent graph, except it's just got a vertical and horizontal shift. Oh, this is when we just did it. I hate when they do that. We've already done these. Sorry. Okay? All right. Here is a problem that a lot of people skip on a test. Why? Because it's got words in it. So read it, write it down. Go ahead and take a minute and write it down. Because all you're doing is plugging and chugging. And get your calculators out. Because we're going to graph it also. I wish they'd make a toothpaste and a mouthwash that didn't chemically go against juice and vodka. It's not vodka, it's juice, okay. Somebody will tell my boss it was vodka. Believe me, if it was vodka, you'd smell it. Like the teacher that decided to bring red Solo cups into his class every morning. He was fired. Some of these teachers are dumb as rock. Thank you. Yep, I'm just going to be an alcoholic in front of my class from 8 o'clock till 2 o'clock and act like nothing's going on, you know. They're not going to smell it. I told you about the speech teacher. that decided that he was going to show a movie in the middle of class, you know, and it was soft porn.
Yeah.
I told you about that.
No.
Oh, we've had some doozies. Let me tell you, we've had some. I don't know what. You ever hear that saying? What the hell were they thinking? We've had some doozies. We had one that just decided he'd just start charging for grades. And then we had the one Spanish teacher, he wasn't bright at all. You know, if you're going to do something, I'm just going to say, inappropriate, illegal, something to get you fired, something to get you written up, because I don't want you to think a certain thing, okay? But anything that's going to get you in trouble, if you're going to do it in your office, please at least lock the door. That's all I'm going to say. We've had some doozies, let me tell you. I could never think about doing some of the stuff that some of the teachers have done. Red Solo Cup, I mean, I just couldn't. Y'all ever heard of teachers doing stuff like that? I mean, at your high schools, y'all never had a teacher at your high school do something really stupid and get fired? What?
I had a teacher that got the juice.
Oh my God! Not instead of go to YouTube
I
movement.
couldn't never.
Oh gosh, that's like Creepy Joe Biden. Y'all seen the videos of him rubbing on? Boom, he's creepy.
He said if you wore ponytail to class.
He said what?
He said if you wore a ponytail to class.
Creepy Joe. Y'all need to watch that video on Creepy Joe. They compiled a bunch of times when he goes around women. Oh gosh, it is bad. Got these little girls going like this, away from him. And Bernie, he can't punch a punching bag. Did y'all see that video? He punched a speed bag and it hit him in the face. Just love how these politicians try to pander and try to be a normal person. That's like some of your professors trying to be a normal person. They can't. Some professors just can't be a normal person because they're not. And I don't mean that in a good way. I mean it in a not good way. Anything, Pendleton? Any teachers do stuff weird? Oconee?
Nothing I can think of.
Golly, you must come from a normal high school. Where'd you go to high school?
Oh wait, Jerry Lee was a creeper.
Where's that? Oh, what?
Jerry Lee, he was a creeper. He was a PE coach at our school.
What school?
Walhalla.
Oh, so you went to Walhalla.
Yeah,
Oh, I didn't mean to discourage Walhalla a while ago. Sorry about
it's
that.
alright.
I mean, I'm just realistic. I mean,
Yeah.
anybody in Oconee?
Can't say that I have, no.
You'll have to watch the video on Joe Biden. That's funny. And I really don't know if he knows what year it is or not. I really don't. But Bernie's going to take care of it. He's going to fight for you. Punching bag. Okay, that's funny. I love the and Gildebrand. She was even more funny. If you told her that you believed the sky was red, she'd go to give a speech on why the sky is red. I mean, she was just pandering to anybody, and she couldn't even get 1% of the vote. It was sad. Some of these people, these politicians are unreal. Okay. So, what do you do whenever you have a 2 in parentheses right here with an F? Plug and chug. So that'll be 233 times 2 plus 200. That'd be 466 plus 200, which is equal to 866. Or you can go to your handy dandy calculator.
That's not 866.
Okay, 666. Dang old mark of the beast.
Oh, you knew it was.
Dang old mark of the beast. Okay, let's go to our handy dandy calculator. No, I don't want to discard. Oh, what did that loser want? Duh. Let's see what you want. Let's see, how do I get out of here? I want to keep it. There we go. All right, let's go to my handy dandy calculator.
Oh, I thought you were going to a thing.
What?
I thought you were going to your thing.
I am. I'm going to see what she wants. She probably wants money.
Okay.
Okay, somebody give me the function. Y is equal to what? What was the function?
233x
233x plus 200. So go there, and you can do two or three things. You can draw a line, or you can go to the table, and the table's the easiest thing to do. Go to the table, and what did they say? Find f of 2? What is f of 2? Dang old mark of the beast. Dang old Armageddon. Judgment Day. The woman said she was offended. It's a dang movie. Okay, 666. Okay, it's about time to go. Some of y'all going into convulsions, so. Now, what you need to be doing right now is working on your, what does she want? Changed her cover. Oh, she went to the game. Oh, God. I'll put you suck on there, but I'm not right now. Okay. Let me go ahead and get the roll. Y'all start sending questions, hopefully. But like I say, eventually, y'all are going to start sending questions. I'm not worried about it. But exactly, we're going to keep on running. Let me go ahead and do Pendleton. What section are you, Pendleton?
110, 111.
Okay, I'll go down here then. And we only got one today.
Yes.
And you are
Thank you,
Mr. what?
Reese.
Mr. Reese? So
Yes.
I'll say no and put a yes beside Mr. Reese. Okay, you can go. Okay, who's next? Let's do Anderson next, or Oconee next. Oconee is 10, and y'all are both here, so y'all can go. Have a good weekend. And now Anderson, how many we got? 5. Everybody? Okay, so y'all can go. Unless y'all got questions, y'all can go. Have a good weekend. Work on problems and send me questions. You should be up to 2.2.
I said, let me take a pause and then.
Pause.
Why did you just sing that song?
I was singing that song about it.
All right, y'all be good.
You too, sir.